So again, that's just your basic parent graph for sine. So we have to think about what the inverse of this graph is going to look like. Do you guys remember anything about inverses from Algebra 2? X and Y are swapped. Good. That's what happens with inverses. So think about labeling your X and Y axis. I should swap those, right? So the -1 to 1, instead of being on the y-axis, is now going to be on the x-axis. And then you can squeeze it in here up to 2 pi y-axis. Okay, so with the inverse, you switch the x and y labels. Alright guys, let's think about our points now. So this first one in the center here is 0, 0. So if I switch x and y, it's still 0, 0, right? Okay. Next point over, I've got pi over 2, 1. So what am I going to plot on the inverse?
1.
Exactly, so over 1 up pi over 2. I'll keep labeling a few of these here. This is going to be pi 0. So I'm going to graph 0 pi. And my regular graph is 3 pi over 2, -1. So I'll do -1, 3 pi over 2. 2 pi 0 becomes 0, 2 pi. You can certainly keep labeling the points on the sine graph, or you can start to follow the pattern and do the bottom half of your graph here. Apply your points. Connect. So what do you think? That inverse graph I drew, is that a function? It's not. Why? This morning no one remembered what a function was.
Vertical line.
Exactly. A vertical line would cross it more than once. So what we have to do is pick a specific part of this graph to use that would be a function. Still needs to cover everything from -1 to 1 as far as x values. Do you guys see a window that I could look at that would only give me a function?
In between -5 or 2 and pi over 2.
Perfect. Yeah. So guys, what if I look right there? Okay, that's a function, right? Okay, so that's the section I want to use. So the next little part, the range that we would pick has to be from -pi over 2 to pi over 2. Okay. So this is the only part of the graph we get to look at. I'm not going to use this, the restricted graph looks like, cross that part out. Okay. Looks exactly the same as it does up above. For notation purposes, I'm sure last year, did you guys see like the little -1 for f of x, the inverse of function, or maybe you even saw that every once in a while. That means inverse, so g of x equals inverse sine of x, or if you see arc, that means the exact same thing. So it's just two notations that mean the same thing. Okay? Very good. Okay, so what we're actually going to do with this, I'm going to draw a circle on this little graph here. And now let's think about the range we're talking about. It has to go from -π/2 to π/2. So on your unit circle, guys, where is -π/2? Yeah, down at the bottom, right? -π/2, isn't that down there? Okay, where's +π/2? Top, okay. Squeeze that in. If I'm going from -π/2 to +π/2, this is the only part of the circle I can look at. So I'm going to go ahead and label the normal spots on the circle here. So I've got π/3, π/4, π/6, 0. Now guys, when we get into the fourth quadrant, Chris?
Would that be -3π/2?
It is +3π/2 or -π/2. Remember, negative angles just mean you go backwards. So like right here, if I went all the way around the circle, this would be 11π/6, right? Okay. I don't want to use 11π/6, so what's another way I can name that?
-1/6? Oh,
That's what we're doing, yeah. And now, if I go back up to the graph up here, because you said, like, isn't that 3π/2? 3π/2 is up here, right?
Yeah.
Okay. Is that in this little window that we can use? No. So that's why we don't call it 3π/2.
Wait, can I use the window between π/2 and -π/2?
Yep. We can only use values within there.
So we only graph those values? Is that what you're saying?
So the graph, like this graph, we only care about the part in between -π/2, and on the circle, like we just label the right side of the graph.
Do we only write the function for that part of the graph? Is that what you're talking about?
Yes, because it's not a function if you go beyond that. Is that what you mean?
Oh, yeah.
Okay. So what you do with this to actually answer questions, so the first one here, inverse sine of 1/2. I'm asking you what angle has a sine that is +1/2, and the only choices are the ones from this restricted part of the circle, okay, the right side of the circle. So guys, remember sine is your y value. So out of those angles I have labeled, which one has a y value of 1/2? Okay, is it both π/6 and -π/6? Just positive, yeah, because I want it to be a +1/2. Okay, like if you want to, you could go ahead and label all your coordinates here. You guys remember this? √3/2, 1/2, √2/2, √2/2. So that circle and all those values that I keep telling you you need to know, again, you need to know them. So this guy's 0. Okay. So again, all we're talking about right now is inverse sine, so that's only y values. So let's look at letter B here. Inverse sine -√2/2. Those are my only options. Where is the y value? Negative root 2 over 2. Perfect. Negative pi over 4. Does that make sense? You're just working backwards. You're telling me the angle now instead of me giving you the angle. So letter C, inverse sine positive root 3 over 2. What do you think?
I have a question.
Mm-hmm.
So if like cosine comes in, it's like that's like the x value you do.
But it's a different part of the circle, so
Yeah.
yeah. Yep. All right, what do you think for C? Pi over 3, good. And then D, inverse sine of 0. Where's your y value 0? Okay. Where is y 0? Okay, is 2 pi in this interval? Yes. I know they're in the same spot, like they're coterminal angles, but you have to give the one that's actually in the restricted part there, okay? All right, questions so far? Okay, the part at the bottom here, we're not going to write it out. Y is inverse sine of the sine of pi over 6, pi over 6. Why is that true? But inverse sine of the sine of 5 pi over 6 equals 5 pi over 6 is not true. Guys, is 5 pi over 6 an answer you can get from doing an inverse? No, so that's why it's not true. Like, it's not a valid solution for an inverse. But again, we're not gonna, that's not a big detail you guys need at this point. All right, so let's try again, but with cosine. Yeah, okay.
Will we be graph these on the circle? Will we just get these together on the sine?
Yeah. It's just the questions of like this. The graph is just so you understand why. So I'm not just like, oh, use this part of the circle. There's a reason why we don't do this part of the circle. All right, guys, so graphing cosine. There's parent graph of cosine.
Can you go over the examples one more time?
Like back to these,
Yeah.
like A, B, C, and D.
Yeah.
Okay. So all you're doing, inverse sine of 1/2. You know sine is the y value,
Yeah.
right? Out of these choices, where is the y value 1/2?
Oh, where the y, and then if it's not inverse, then it's,
We're only doing inverses.
okay, we're only doing
Yeah.
inverse.
Because if it's not inverse, I'd have to ask you like the sine of pi over 6, which is a totally different question.
So the inverse is the y value, where's the y value?
No, the inverse is asking what angle has this. If we're talking
Y.
sine, it's a y value, cosine is an x value.
Oh, so it's cosine or sine.
It's still back to that stuff
So
that,
it's what angle has that, so pi over 6 equals that.
that makes sense what we're looking for?
Oh, yeah.
Okay.
And you're only working on one side, so you can find it?
Well, we had to restrict the graph so that it was a function, yes. And so that limits us to just those values, like that half of the circle.
What happens if, like, in a problem, like on a test or something, what would happen if none of them had that?
I'm only asking you things from your unit circle right now, so, and every value is covered in the unit circle. because that's the other piece. By picking from negative pi over 2 to pi over 2, we covered every value from negative 1 to positive 1.
But like, say it was like cosine, inverse cosine.
Well, cosine's going to be different.
Oh, it's like,
We've only done sine so
Yeah.
far.
thank you.
Yeah, did you want to ask it with a sine? Like what you're thinking of?
Just like, is it like no solution? Like, the question asking you for an answer that isn't there?
Like, give me an example.
Like, will there be like any trick questions?
Like sine of 5 pi over 6.
Yeah.
Well, sine of 5 pi over 6 is different than an inverse sine.
The inverse one.
So if I ask you inverse sine, it's never of a radian. Do you see how your answers are the angles? But in here, they're just like pieces of the ordered pair.
Oh, but like, if we could only have like the top part, for example. Sorry, this is.
You're not going to use the second quadrant for sine.
Okay.
Okay.
If you could only have like, is it possible to only have like the top, like, right corner? The first quadrant?
You can use the first quadrant. If it's inverse, you will use first and fourth quadrant
Okay, always?
for sine. Yes. Let's go through cosine and see if that clears up any other for you. Okay, all right. All right, so, oh, guess, Haley.
When are we done with trade?
Not yet. We got a little ways, little ways to go, but not too far. But those trig quizzes last all year. Just so you know.
And we have until the end of the year to get courses.
You'll keep having them for the rest of the year. So each quarter, you're going to try to get your 4s on it. You know what I mean? Like it'll start over in the third quarter. Yeah. But it's the same stuff. You know what I mean? How many standards are trig based? I can look it up for you here in a second. All right, guys, there's your graph for inverse cosine. What's wrong? For sure. Sam, what you doing? All right, guys, do you think we want to use the same window? Like, does negative pi over 2 to pi over 2 make sense this time? No, that's not a function, right? So,
What is, like, what are you looking for?
when I say, like, that's not a function,
Yeah.
so if I look at that piece, if I drew a vertical line through the graph, how many times would it touch the graph?
Twice.
It can't be a function if it touches it more than once.
Okay.
Okay?
Oh, not one. Okay.
You see it?
Yeah.
Okay. So any guesses as to what window we might want to use?
0 to pi.
I like 0 to pi. There are other windows that would give you a function, but this is the like universally accepted one that we always go with. So that's from 0 to pi. Okay? So I'm going to draw another circle for you just so we can think about what that actually means as far as our answer options. So guys, there's 0 and there's pi, right? So I can only use this part of the circle. Which means I'm going to have just the normal labels. So for inverse cosine, those are your only answer choices. You're not going to tell me negative pi over 6 this time, okay? You can only give me answers between 0 and pi. So does it make sense to you guys why it's a different part of the circle than the sine one?
That's for the inverse, right?
Yeah, so this is for inverse cosine. Yes. So let's try to do a couple here. So the first one, it says inverse cosine of 1/2. So you're thinking about this part of the circle. Cosine is your x value, right? So where's the x value? Positive 1/2. What do you think, Chris? X value positive 1/2, guys. Where does that happen? Pi over 3. I didn't hear you the first time you said it. Is that what you said? All right, guys, next one, inverse cosine 0. I am asking you what angle has an x value of 0? Pi? No, that x value is negative 1. Yes, pi over 2. Good recovery. Okay, next one, inverse cosine negative root 3 over 2. Guys, it's negative, so it cannot be first quadrant. It's got to be second quadrant. What do you think? What do you say? 5 pi over 6. Good. Then letter D, inverse cosine negative root 2 over 2. What do you think, guys? Yes, 3 pi over 4. Questions so far, guys?
I see this sort of one more time.
What? I'm sorry.
I see it sort of one more time.
That? Did you forget your circle?
I forget like the 2 pi over 3.
Does it make more sense?
Oh, it makes sense. It's
Okay.
like,
All right, guys, questions before we look at tangent? It's the last one we're going to draw a graph of. And again, the graphing is not what I'm going to ask you questions about. It's just so you understand why we only use part of the circle. Okay? All right, so parent graph for tangent. I'm only going to graph out to the first asymptote. So I'll do that for my tangent graph. Go ahead and switch your X and Y axis labels. what kind of asymptotes do you think we're going to have for the inverse graph? Oh, yeah, so pi over 2.
Oh, that's another one.
There's the shape of your graph. So guys, what do you think the window is going to be for this one? Same as sine, yeah, negative pi over 2 to pi over 2. You can see how the asymptotes kind of lead that to happen for you. So, just like with sine, I'm now looking only this side of my circle. Okay, those are the only answer choices through there. You can relabel them if you want to. But what do you think, guys? Inverse tangent of 1. Remember tangents, y over x. From negative pi over 2 to positive pi over 2, where does tangent equal a positive 1? Do you know your trig values yet? Not pi over 2, pi over 4. Yeah. We're skipping letter B because that one's not one you're going to have to do right now. All right, C, inverse tangent root 3 over 3. It's positive, so it's got to be first quadrant. Over 6. Pi over 6. Know your shortcuts, guys. So then D, inverse tangent negative root 3. What do you think? Negative pi over 3. Good. Okay. Are we catching on? Okay, guys, so somewhere I want you to sketch these two circles for me. These are the two options we have for all of our inverses. We've talked about how inverse sine and tangent is this first one. And inverse cosine is this one. We're not going to graph secant, cosecant, and cotangent, but we need to figure out which part of the circle they actually are connected to. So I'll give you a second to jot these down. The scribbling is like we can't use quadrant 2 or 3. We can't use quadrant 3 or 4, okay? So find somewhere to put these. Nope, you don't have to. Like I want you to label just like the right side of the circle or the top side of the circle, just like so you understand which half we're working with. So inverse sine, inverse tangent are the first one. Cosine we know is the second one there. What we have left is cosecant, secant, and cotangent. So guys, what is cosecant connected to? Sine, so it goes with this first part. Okay. So those three go with that. What is secant related to?
Cosine.
So it's going to be over here. Now, cotangent, yes, it is related to tangent, but if you think about the asymptotes of cotangent, they're actually at 0 and pi, so inverse cotangent goes with the second option here. Okay? So based on the problem, whether it's inverse any of these 6, you have to know which half of the circle you're talking about. So we'll practice a few more here. All right, guys, so find this page for me. The directions at the top here, like the steps, that's only if it's not on the unit circle, so that's not something we're dealing with initially. I want you guys to try 1, 2, and 3 for me. I'll walk around and see how you're doing. It shouldn't take you too long. Check with your neighbor. I go through a bunch of these. Arc is the same as inverse.
Is it versus the same as -1?
Yes.
Cosine.
Check with your neighbor. All right, guys, let's look at them. So number 1, arc cosine root 2 over 2. Did you guys get pi over 4? Yes? Okay. Number 2, what do you think? Good, negative pi over 4. And then arctan root 3? Pi over 3, yes. You guys not know your shortcuts yet? Remember, tangent of anything over 6 is root 3 over 3. Tangent of anything over 3 is root 3. Okay, let's do 4 together. I know we're running out of time, guys. So inverse cosecant. What is cosecant related to? Sine. I would do this as a sine problem because I don't want to think about cosecant. But instead of 2, what do you think I'm going to write? 1/2. Good. So could you tell me inverse sine of 1/2? What's that going to be? Pi over 6. Yes.
Yes.
Okay. All right. So number 5 is a secant question. I would do that as a cosine question. What's the reciprocal of negative root 2? Yes. So I'm asking you, where does cosine equal negative root 2 over 2? Not negative 3 pi over 4, but just 3 pi over 4. Okay? Remember, with cosine, you're never going to have negatives in front of your angles. All right. That makes sense? Okay. All right, 6 is cotangent. Don't think of it as tangent because they're different parts of the circle. Cotangent is the top half. So where up there is cotangent equal to -1? not pi over 2. Not pi.
Oh,
That's the same as pi over 2, still no.
I mean, no, just pi.
No. I'll go back to it in a second here, Betty.
Sorry, I just.
Jack, do you have to have it written down for her? Which one's going which? Half? Does that make sense why it's 3 pi over 4, guys?
No.
Okay. Cotangent is x over y. So at 3 pi over 4, that's negative root 2 over 2 over root 2 over 2. So it's negative 1. Yeah? Okay. All right. Let's look at 7 here. What's happening on 7? I don't know. It's just 2 problems in one. Just start on the inside and work your way out. So arc sine of 1/2. What is that? What angle has a sine that is 1/2? Pi over 6. So I am now asking you the cosine of pi over 6, which is root 3 over 2. Good. Guys, if you don't know your unit circle and you don't know your trig values, this is terribly hard, okay? If you do, it's really not that bad. All right, let's do 8. So start on the inside, inverse cosine negative root 3 over 2. Where does cosine equal negative root 3 over 2? What'd you say, 5? How about 5 pi over 6? Because it's negative. And then what's the cosine of 5 pi over 6? Do you see how you just kind of ran in a circle here? Okay. See it? Okay. I want to do one real quick that's different. Let's look at 10. So if I start on the inside of that, our cosine of 3/5. Is 3/5 on your unit circle? No. So what I have to do with this is draw a triangle based on what it's telling me. All right, it's arc cosine. My only choice is first or second quadrant. Where do you think I'm going to put it? First. Why? You're right, but why? It's positive, yeah. So I'm going to draw a little triangle. The cosine is 3/5. That means adjacent is 3, hypotenuse is 5. What does that make the other side? 4. Okay, guys, the entire purpose was just to figure out what the triangle is. Now I can do the sine of theta. So what's the answer? You guys see it? It's 4/5. So if it's not on your unit circle, all you are doing is drawing the triangle so that you can answer the rest of the question. Let's do 11. It's the same idea. So I start on the inside, inverse cosine of 3/4. Where am I drawing that triangle? Nope. Cosine, my only choice is first or second. It's positive, so first again. So I know adjacent is 3, hypotenuse is 4. Do I need to find the other side of the triangle on this one? No, because I'm asking you what's the secant. So what are you going to tell me? 4 over 3. And are we okay with the other side of that triangle is not 5? Okay, good. All right, that's where we're stopping. Your homework. Guys, it's only one page. It's the one side says classwork, the back sentence says homework. Only do the homework side, and you can just do evens for me, okay?
Evens?
Evens.